In this example, you're asked to prove that sine of pi over 4 plus x is equal, or sine of pi over 4 minus x is equal to the square root of 2 cosine x. In verifying this identity, well, so a couple of things. First, you should start with the more complicated side, which in this problem is definitely the left-hand side. You've got a lot more going on over here than over here. Okay, so if we start by writing down the left-hand side, which is sine of pi over 4 plus x, and I'll leave some space here, minus sine of pi over 4 minus x. Then the next thing to do would be to apply the appropriate angle addition or angle subtraction formulas. The formulas that I've written here in red. So I went ahead and copied those down, and you can find those in your notes. And we're going to apply that to what we have here on the left-hand side. So starting with the sine of pi over 4 plus x. So applying this formula right here, that's equal to sine of the first angle, which in this case is pi over 4, times cosine of the second angle, which is cosine of x, plus sine of the second angle, which is sine of x, times cosine of the first angle, which is pi over 4. Okay, so all of that comes from the sine of pi over 4 plus x. Now, let's see, I'll choose another color. If we apply that second formula to the sine of pi over 4 minus x, so apply this formula right here, that's equal to sine of the first angle, so sine of pi over 4 times cosine of the second angle, cosine of x, minus sine of the second angle, so that'd be sine of x, times cosine of the first angle, so that'd be cosine of pi over 4. Now, one last thing to be careful of here, notice you've got I was going to say we were subtracting, but if I look back at the original, we're supposed to be adding here, add these two values of sine, so this should be addition here. So this should be addition here. I was going to say, so watch it in your homework if you have subtraction of these two quantities, then you would have to distribute the negative to both parts down here once you apply the formula. So just watch out for that. Okay, we don't need to here since it's a positive in front. So now you would just evaluate. Sine of pi over 4 is equal to the square root of 2 over 2. You can find that value on a unit circle if you like. Times cosine of x, which cosine of x, we can't do anything with that, so you just leave it alone. Same with sine of x right here, we just leave that alone. But cosine of pi over 4 there, that's also equal to the square root of 2 over 2. So we've got plus the square root of 2 over 2 times sine x, okay, plus cosine x times the sine of pi over 4, which is equal to the square root of 2 over 2, times cosine x, minus sine of x times cosine of pi over 4 is also the square root of 2 over 2. It's all square root of 2 over 2 there. Okay, now we would want to combine like terms. Notice that we've got a positive square root of 2 over 2 times sine x, and then a negative square root of 2 over 2 times sine x. So those are going to go away. The net quantity of sine of x's that we have is 0. The square root of 2 minus square root of 2 over 2 minus square root of 2 over 2. If you add these guys, so the square root of 2 over 2 cosine plus the square root of 2 over 2 cosine, so if you think of this as half of a square root of 2 plus another half of a square root of 2, what you get when you add those would be a whole square root of 2 cosine x. And so we've reached the right-hand side. If you're not thrilled about the last step, the way I explained that, then you could think of it this way. Add the coefficients. That's how you figure out how many cosine x's you have. When you add those right there, and I'm going to run out of room here, I'm going to try to squeeze it in. You have the same denominator, so you can just add the numerator. Square root of 2 plus square root of 2 would give you 2 square root of 2 over 2, and then cancel, if you like that better.